Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. And in this video I want us to look at example 5 of topic number 2 of Pure Mathematics 4. Incidentally, this happens to be the very last example in that topic, partial fractions. And you're told that express 3x cubed all over x minus 1, x minus 2 is partial fractions. And this one is going to show us exactly what we have been talking about, that the index or the power at the numerator is greater than the power at the denominator. So that to me is an improper fraction. Please note the power at the numerator, which is power 3, is greater than the power at the denominator, which is power 2. That to me is the meaning of an improper fraction. Well, and I think what we need to understand is that we can already rewrite this one in terms of, if we just get it like 3x cubed all over x minus 1, x minus 2, x cubed divided by x squared is an x. And x, because we are talking about 3x cubed divided by x squared, we are simply going to talk about 3x. But let's just assume we don't know even the coefficient of the x and call it ax. This power is power 1. We need to bring in another term whose power is power 0, and you're going to have plus b x raised to power 0 before we now bring in the divisors. Then plus c all over x minus 1 plus d all over x minus 2. For one reason, that x cubed divided by x squared is x, and this x is to power 1, must be followed by another term which still has x but x to power 0. So the indices of x have to decrease systematically. Power 1, power 0. So when we write x power 0 here, of course any number to power 0 is 1, and of course 1 times b is b. And that is just like it, exactly what we wanted. We can say this is over 1, or we can even deal with it independently. So the LCM, as we know it, is going to give us this divided by 1. We're going to have ax plus b multiplied by x minus 1, x minus 2, plus c x minus 2 plus d x minus 1. Everything over x minus 1, x minus 2. Remember, we've divided this LCM by this to give us the whole of it. Divide the LCM by this to give this one, which multiplies out c. The LCM divided by this to get this one, which multiplies out d. And this is basically equals to 3x cubed over x minus 1, x minus 2. At that particular point, we all know that to determine a, note that we can see somewhere at the peripheral that 3x cubed all over x squared plus the rest The very first time is going to be 3x, and this a has to assume 3x. So in other words, you're going to say that 3x cubed is equals to 3x plus b, 3x plus b, x minus 1, x minus 2, plus c, x minus 2, plus d, x minus 1. We have something like that. And now we have reached a stage whereby we need to nullify some brackets. And the very first one, we can nullify the whole of this term, including this term, by letting x be equals to 1. When x is equals to 1, the left-hand side you're still going to have 3, because 3 times 1 squared is just 3, is equals to, this bracket becomes 0, nullifying the whole of this expression, or the whole of this term. This 1 minus 2 is minus 1, minus 1 times c is minus c, and the whole of this term becomes 0. So, in a nutshell, what we are having here is that c is equals to minus 3. We have our c there. We need to nullify another bracket, and we can nullify now this term by letting x being equals to 2. So when x is equals to 2, we are talking of 2 cubed is 8. 8 times 3 is going to be 24. And when x is 2, 2 minus 2 is 0. So the whole of this term again becomes 0. The whole of this term is 0 because x is 2. 2 minus 1 is 1. And we can already see this is equals to d. Having found d, we realize that on the right hand side, we cannot make any other bracket being equals to 0, because we have dealt with this bracket, we have dealt with this bracket, we have dealt with this, we have dealt with all the brackets and nullified them. So the only thing we need to do is to go to the left hand side and try to make the whole term 0 by letting x being equals to 0. So when x is equals to 0, again, the whole of this term is 0 is equals to, let's talk about 3 times 0 is 0 is equals to b multiplied by negative 1 multiplied by negative 2. This is 0 minus 1, and this is 0 minus 2, which is still minus 2, plus 0 minus 2, this is minus 2c, and this is plus minus 1d. But look, what do we have? We have c, we have d, so we can substitute all this in this particular expression. We have c, we have d, and of course a we know it's 3. Having said that, 0 is going to be 2b, c is minus 3, so minus 2 times minus 3 is 6, so plus 6. D is at 24, plus minus 24, so minus 24. Meaning that directly 2b is equals to 24 minus 6, which is what? Which is 18. Which is 18. And b is easily a 9. So at the end of the day, we can express the whole of this expression in terms of, yes, 3x cubed all over x minus 1, x minus 2 to be exactly equals to 3x plus 9, 3x plus 9, which is plus, what is c? let's first of all bring in d plus 24 all over x minus 2 minus c, which is minus 3 all over x minus 1. And that is just like what we wanted to express. At this particular point, you can see that this one is reflected here as our final submission. Please remember what an improper fraction is and don't get confused. And even with this example, this becoming an improper fraction, and that's why we have constants after dividing. We have had x cubed divided by x squared, and you can see the power at the numerator is greater than the power at the denominator, and that is exactly what we expected. So moving forward, please note what an improper fraction is and how to express it in partial fractions. Well, that is the end of the topic, and let's be on the lookout. So thank you so much.